Hey everyone, welcome back to Physics with Diaz. Today we're going to talk about one of the most interesting and visual topics in physics, that is projectile motions. For example, if you ever thrown a ball, kicked a soccer shot, or seen fireworks in the sky, well, you have seen projectile motion in action. First of all, what is projectile motion? Projectile motion happens when an object is thrown into the air and moves under the influence of gravity only. After it's launched, no engines, no pushes, just gravity pulled it down. It follows a curved path called parabola. With this parabola, we can break its motion into two components. That is the horizontal, that is the constant velocity, the one that has no acceleration, and the vertical, accelerated motion due to gravity. The two happen at the same time. That's what makes projectile motion special. There are some key equations in projectile motion. These two equations are: for horizontal motion is equal x equal vertical times time, and for horizontal is equal y equal vertical motion in the y-axis times time minus 1/2 times gravity times time squared. These are the two key equations that you have to always remember in projectile motion. I have to erase this and pass to the next slide. That is the real life applications. Projectile motions is applied in a lot of things in the real life. One of the most specifics are the engineer in space, and one that we all make use of this are in the sports. For example, when you kick a ball, when you throw a basketball ball, all that use projectile motion. Okay, now we have the example that says a ball is kicked with an initial velocity of 20 meters per second and an angle of 30 degrees above the horizontal. We have to calculate the time of flight, the maximum height, and the horizontal range. So the first step to solve this is to break velocity into components. How? Well, velocity in x and velocity in y. In x, well, it is equal to 20 cosine times 30 of the angle, and that gave us 0.3 meters per second. That is the velocity on x. In y, what is the velocity? Well, 20 sine times the 30 degrees, that gave us 20 meters per second. Okay, we have the velocity in x and y. Now we can find the time of flight. How? Well, the total time is given as time is equal to the velocity in y over the gravity. This is 2 times 10, that is the velocity on y, times gravity, that is 9.8 meters per second squared. And how many that those gave us is 2.04 seconds. Now we have the check of the first thing, the time of flight. Perfect. The maximum height. How? Well, with the formula of height, that is velocity on y squared over 2 times gravity. Okay, that is equal to 10 squared over 2 times 9.8. that gave us 100 over 19.6. Sorry, that is 19.6. And simplifying that gave us 5.1 meters. We have the maximum height, perfect horizontal range. How we find that? Well, it is the velocity on x times time times time. Velocity on x, that is 17.3, times time, that is 2.04. We put all this in the calculator and we have 35.3 meters. Perfect, we have the horizontal range. And now we have all the statements the exercise have. Time of flight 2.04. What is the max height? 5.1 meter. And what is the range, the horizontal range? That was 35.3 meters. I hope you understand it and pay attention to all I said. So, bye.